Okay, here's the milling fixture. We're going to make the parts for the mill stops on. And this is the part we're going to work on today. It's the major piece of the fixture. And we're going to do the machine work on the right hand end of the part as you see it there. The turning and the milling work so that it could mount on an adapter plate that mounts on the spindle of the rotary axis. Here's the raw stock. It's a piece of 6.5 inch diameter aluminum, 18 inches long. And here's sawing it off the longer bar with the saw. This isn't actually my saw, it's the saw that I rent space from a company called Centerline Manufacturing, and this is one of their saws, their smaller saw. I'm sawing it. This saw sits right behind my machine. They let me use it if I need to saw something here and there. Now I'm indicating the part in the 4-jaw chuck. I decided to machine this on an Integrex machine at work, the multitask machine that I own and use at work, because I didn't think about it, but my little lathe in the garage, the steady rest is too small to hold this piece, and I can hold this up in the spindle bore of this machine. Right now I have a 16.5 inch 4-jaw chuck with a 6 5/8 spindle bore, so I can stick this 6.5 inch piece of aluminum right in the spindle and just chuck onto it in this 4-jaw chuck. I'm just indicating it in here. It doesn't have to run very true really, because it's going to take 200 thousandths off the OD, so I'm just trying to get it reasonable. I mean, I got it running fairly true within about 10 thousandths. The stock's probably not round either, but out here in the end of the part, you can see it's running out like almost 100 thousandths. So I have to bang on it with a dead blow hammer. That little dead blow hammer, I think that's a 2.5 pound one, didn't get the job done, so I switched to a 4 pound one. I was hitting it really pretty hard right there, so it just wasn't really moving. So I went back to chuck and checked it there. It was running out a little bit more, tweaked the jaws a little more, and in reality that would have probably been good enough just the way it was, because I'm going to take so much stock off the OD, it doesn't really matter. But I got it a little better, and then I ran out to the end of it again and hammered on a little bit more, but I think I got it running within about 10-15 thousandths there, and it's running out here, so I hit on a little more, and it's, I don't know, probably about 30 thousandths running out. That's good enough for this, because I'm going to take 200 thousandths off the diameter, so it doesn't really matter. I mean, you could spend forever getting everything within 1/1000th of an inch, but what's the point if you're going to machine it off of there? I'm going to take a few little manual cuts on this material. That's kind of speed it up just to get through this tool change. To face the face off clean so I can touch off the face to get my Z0 setting. And I turned a little bit on the OD just to get a good diameter to touch off two tools. I needed to set two tools that I didn't have already set up. All the rest of the tools happened to be left over from a job that I did that were still in the tool changer that I could use. They're already in there. I just needed a grooving tool and a 1/2-13 tap to set up. The rest of the tools happened to already be in there. This machine actually holds 80 tools in the tool changer. It has a Capto number 8 spindle taper on the milling spindle. And like I say, from the previous job, I already had every tool that I needed except for those two. So in order to touch a tool off, I had to turn a little bit of an OD just to get something running true, so I know where I'm at. I can measure the diameter to touch the tool. The particular tap's going to be used on the OD, so I needed to touch it off, and the grooving tool. I need to touch a Z0 on the grooving tool as well, so I need to have a clean face. So here we are changing the tool out of the spindle so I can put my indicator in here. I have this 3D indicator. I think it's made by Hammer, or Hammer. I like this indicator. I've tried various different versions of these indicators, and this one works pretty good. It's not an inexpensive tool. I think it was, well, pretty much like $380 for this indicator, but this one repeats pretty good. It's certainly within a thousandth of an inch. I tried a different one. I bought one from MSC. I think it was an SPI brand, and I returned it because it didn't function properly. This one works pretty good, though. I think Big Daisho or Big Kaiser sells that hammer stuff. This is facing the face of the tool. I'm trying not to use any more coolant than possible here because it splashes up onto the camera and you can't see anything, you know, if you get the camera covered with coolant. I don't know, I've got some ideas. I think I need to put something like a little air, maybe a piece of tubing that runs air and that blows it across the face of the camera right at the lens. Some kind of thing like that will blow the excess coolant off of there, so even if you splash coolant on it, it would blow off. The film of coolant would get blown off of there, so you could see still, and it wouldn't be blurry. You'll see later on in the video, the coolant gets on there a little bit, and you'll see what I mean. I got to do some experimenting with that. There's something can be done if I'm going to try to film in these type of machines. See there, the coolant flies right on the lens. And of course it's right in the middle where you don't want it, and it tends to run off so you can see again. But I think if a little air jet was blowing, it would just blow it off of there, and it would be a trade-off because you would probably hear the air on the microphone of the camera, but I think it'd be better to see the picture and not worry so much about the air. I sped up through the finish pass there so you wouldn't have to wait for it. Of that. Now we're going to come, I think it's a spot drill coming up next. Oh no, the grooving tool. The grooving tool's coming up next to groove out the groove. This tool, I believe, is a Sandvik tool. It's got a 315 thousandths full radius insert, and I think it'll groove to about 2 inches deep if you needed to. It normally has high pressure coolant jets that you know, flow right on that insert, but I can't run them here. You wouldn't see anything, and they actually will break the shavings. They would break those shavings so you wouldn't have this trouble, but because the coolant on this machine is like it's over 1,000 psi. It might be like 1,500 psi. And it'll actually break those shavings. They have like 3 little Venturi-like jet things that shoot it right on the tip of this insert. But without that, I've got to stop and clear these shavings off. And this machine has these doors you got to open and close. They're automatic doors. You got to hold your hand on 2 buttons at the same time to open and close them for safety reasons. And so I've cut that all out of the video, really, but it takes kind of a lot of time if you got to do that kind of thing. You can't run it with the doors open. You can't turn on any spindle or anything, which is kind of good because if the coolant was flowing, you'd get yourself showered with coolant if you open those doors. Right now the coolant's not really on. I sprayed some WD-40 on those things, but that might have been a mistake because you could see it got on the camera. It's kind of blurry a little bit, but I think you can get the idea. So this is a zigzag roughing pass of this groove, and then it comes back and does a finish pass on both sides like that. And of course you get all these shavings in there. You can't see anything, but and that side did real good. This other side got a little bit of chatter, but that side of the groove is going to be mostly machined away on the fixture, so I didn't really worry about it too much. But the other side actually came out nice and smooth. It did good on that side. Now we're going to change to the spot drill. Spot drill the holes in the face. No, I think we're going to take that back. We're going to rough out the counter bore. Rough for the spindle adapter has a protrusion on it that the set screws come up against, just like if it was a chuck. Well, it is a chuck backing plate for a set true chuck is what I'm using, because the spindle on the rotary table is a A5 spindle nose, so you bolt on this adapter plate and then the chuck bolts onto that adapter plate. And also my little lathe has an A5 spindle nose, so I can actually put this thing in the lathe. You'll see in the end of the video, because I'm going to I have to turn the OD to the diameter I want, and I can do that with the spindle adapter and adjust it true in the little lathe in the garage, and I got to bring it back to this lathe to put a counter bore in the end of the part for the shaft that's going to hold the bearings for the outer support when it's on the milling machine for the fixture, which you may have seen in the little CAD model that I showed right at the beginning of the video. So those pieces still have to be made, of course. I sped this up about 6 times faster than normal, just so we'd get through this thing. I probably could have made it all in one depth of cut, but I decided to go 4 passes. It's 3 passes. It's 3/4 of an inch deep, and each pass is a 1/4 inch deep. And I didn't bother to put a finish pass on the floor, but I did on the bore, because it's not really critical as far as the floor goes. It's just clearance on the spindle adapter. But the bore actually isn't too critical either, because it's I think I pushed feed hold there. It's the reason it's slowed down. It's clearance on it's probably got 60 thousandths clearance on the spindle adapter, so you can adjust the run out. Now we're making a tool change to the spot drill. I tried to give you different views here. It's kind of tricky because you got to stop the machine, open the door, move the camera, close the doors, and you got to make sure you got the camera turned on, or you're doing everything for nothing. So you got to be kind of careful with the camera. I can't tell you how many times I thought I was filming something with a GoPro camera, and I didn't even have the camera on. Sometimes it's a little bit hard to tell, because I really should turn that red light off on the front, because I could see it in the view of the grooving tool. I could see it reflection on the grooving tool. But if you turn that light off, you can't tell if you're recording sometimes. Okay, see, this machine goes up inside a hole kind of with the spindle for the tool change, so I can't really put a camera up there, or the tool change arm will hit it, so you can't see it. I might be able to, maybe in the future I'll put a camera back up in the cabinet there, so you can see the tool change happening, because it's kind of interesting the way this tool changer on this machine works, because it has like 3 different arms. One arm pulls it out of the magazine, one arm runs it forward up to close to the spindle there, and then another arm puts it into the spindle. And it's kind of a complex. See how the coolant's getting all over the camera. So I think if I had that air jet blowing it away, even though it splashes up on there, it would blow it away immediately, and you could see still. So it's something I got to experiment with here. Normally, most of these guys that make YouTube videos are doing on manual machines, and you don't have coolant flowing like this, so it's kind of a different problem. They don't have this problem like that. I would like to be able to film with the coolant going, but it's kind of difficult. So going back to the spot drill, we're going to spot drill the OD holes. Spot drill is a single flute inserted spot drill, 90-degree spot drill. I have found that these tools work very good, hold up very well compared to a normal spot drill in exotic materials like stainless steel, Inconel, nitronic, titanium, these tools hold up much better than a standard like carbide 2-flute spot drill does. You have to feed them a little slower, but you get a lot better tool life out of it. And you can also chamfer with the same tool if you have some 45 chamfers. So it's kind of a nice tool. I kind of like these things. And of course it's indexable, so you don't have to regrind or buy a new spot drill. If you wear it out, you just index the insert. See how noisy that spindle sounds? And literally, when you're really standing in front of the machine, you can't even hear it running. You can't even tell it's running. You have to look real close. It's that quiet. Yet with this camera, it picks up that noise somehow. I'm not sure what it is. It sounds like gears grinding, but the spindle has no gears. It's a direct drive. The spindle and the motor are all integral. There's no gearing or anything, so I'm not sure what's making that noise, but that I hear in the video, but you can't hear it normally at all. It's absolutely silent, yet it sounds like very noisy in these videos. I'm drilling this without coolant just because you saw in the last drill you wouldn't be able to see anything. But normally I'd be running through the spindle coolant on a drill like this. Although it seems to be doing pretty good without coolant. I have a little peck on it, so normally I wouldn't peck a carbide drill, but without coolant I was concerned about shavings. Even though it is aluminum, it probably wouldn't do it, but normally you don't want to peck on a carbide drill with coolant flowing through it, because it actually is harder on the drill than to drill straight in with no peck at all. But it seems to be working all right. Sounds a little noisy, but getting the job done. I'm going to come back with a final tool. It's a 1/2-13 tap. I think I pushed feed hold here because I wanted to stop this before it came down. I wanted to put some oil on there, so I slowed it down, put it in single block here, stopped it. If you look carefully to the left, you can see these doors opening up. The lower left, well, I guess I'd cut it out of the video. I think you'll see them close though after I put this oil on there. Just get a little bit of oil on here. I didn't want to. Once you start a tapping cycle on a CNC machine, the only way you can stop it is to hit emergency stop. See the door closing on the left, the lower left corner of the screen. See how slow those doors close? That's just the way they are. You just can't really do anything about it on this machine. It's a safety deal. You have to open and close those doors. So you can't really brush oil on a tap. You got to kind of put it on there and then run it. And this is a through hole in aluminum, so it's no big deal, but if you're tapping some more exotic stuff, it's kind of nerve-wracking because normally on a machine that you can open the doors, you can squirt a little oil on there, and tap, but you can't do it on this machine that way. So most of the time I try to mill all my threads if I can do it somehow instead of tap holes. This has rigid tapping, of course. We call it solidly mounted tap. It doesn't have to have a compression tap. And that's it. This last little picture shows it mounted in the little lathe in the garage. We're fixing to turn the OD. That's going to be the subject of a next video. So thanks for watching, and I appreciate everybody that subscribed to my channel.